Depending upon the water content, soil may appear in one of these four states: liquid state, plastic state, semi-solid state, and solid state. Water content at which the soil changes from one of these states to another are called consistency limits. These limits are liquid limit, plastic limit, and shrinkage limit. In liquid state, water content of the soil is such that it behaves like liquid and offers no resistance to flow. When water content of this soil drops, it gains shear strength and develops resistance to flow. After reaching certain water content named as liquid limit, soil enters into a state called plastic state of soil. In plastic state, soil can be molded in any shape due to a property called plasticity. When water content of the soil is further reduced, after reaching another certain water content named as plastic limit, soil enters into another state called semi-solid state. Here we define a quantity, plasticity index, which is the range of the water content over which the soil remains in plastic state. We represent plasticity index as Pi or IP, and it is defined as the difference between the numerical value of liquid limit and plastic limit. We need to keep in mind that these limits are nothing but the water content values at which soil changes its behavior. Plasticity index shows the size of the range of moisture content at which the soil remains plastic. Usually, plasticity index depends on the amount of clay minerals present in the soil. A high value of Pi indicates an excess of clay mineral in the soil, and that results in greater plasticity of that soil. If soil's plasticity index is small, which means this range is small, that shows soil is plastic for a very short range of water content. This soil can hold very less amount of water, and with little increase of water, it reaches to its liquid limit and starts flowing. We know water molecules are held by clay particles. So, low Pi value or small water content range displays that soil contains less number of clay particles. Hence, they capture less amount of water to make the soil plastic. While high Pi value indicates soil can hold large amount of water in it and still manages to stay at plastic state. It can hold more water into it because it contains large amount of clays, hence highly plastic soil. Soil may be classified based on plasticity index values. If soil has Pi value less than 7, then it is described as less plastic. If it has Pi between 7 to 17, it is medium plastic. And if its Pi is greater than 70, then soil is highly plastic. Coarse grained soils cannot achieve the plastic state of consistency because soil needs clay minerals to become plastic, which coarse soils does not contain. Their liquid limit and plastic limit are said to coincide because at higher water content, soil starts flowing without even reaching at plastic limit. Also, in some cases, plastic limit of soil is found greater than the liquid limit. Or in another cases, both plastic limit and liquid limit cannot be determined. In all those conditions, soil is considered to have plasticity index 0 and is reported as non-plastic. Organic soils have high liquid limit and high plastic limit, so they have very low value of plasticity index.